Okay, we're going to do another one, factor the trinomial. It could say factor the trinomial. It could say just factor. It could say factor completely. The key word is factor. The only time you wouldn't necessarily use this method is if they just say factor the GCF. Factor the GCF is just using step 1 of our process. So if the directions say anything about GCF in them, like factor the GCF, they just want you to do step 1. If they say factor by grouping, then you need to do step 8. And if it doesn't have 4 terms, you're going to have to do this whole process to get there. But the directions, if they just say factor completely, factor the trinomial, and so forth, then you have to do all these steps, okay? So we're going to start with step 1. Is there anything common to all 3 terms? And I don't see anything in common to all 3 terms, so step 1 is done. Step 2, multiply the first and last digits. So it's going to be a positive 6 times a positive 10. So 60 is the number that we get for step 2. And it's a positive. Step 3 is make our list. Now, again, it's important that we do this in a specific way because it's just going to bless us later and make life so much easier. So we're going to list the factors of 60, but we're going to do them in a very specific order. We're going to start with the number 1 first and say, yep, 1 times 60. And then we're going to go to the next smallest one. So after 1 is 2. 2 works, so 2 times 30. And each time I'm putting the smallest number on the left. I'll show you why in a minute. I showed you in previous videos, but it's super important we do it this way because it just makes life so much easier. Okay, 3 goes into 60, so 3 and 20. 4 also works. 4 goes in there, let's see, 15 times. And you can use your calculator, do 60 divided by 3, 60 divided by 4, 60 divided by 5, and just pop those into your calculator and figure out what it is. 6 goes into 60, of course, is 6 times 10. 7, 8, and 9 don't work. Now, when I showed this to you earlier, I told you we would always know when we're finished because when we wrote the first set, 1 times 60, we knew that after that set, the next set had to come from between these 2 numbers. And sure enough, 2 and 30 are between 1 and 60. So then when we went from 2 to the next number, we knew whatever set came next, that had to come from between the numbers 2 and 30. And 3 and 20 are between there. So what's happening is we have 60 numbers to think about in the beginning, and it's like, whoa, that's a lot. But as soon as we start doing it with the smallest number first, we start eliminating all the numbers between 60 and 30 are done. Just by that doing 1 and then 2. So that eliminated half of our numbers. Then, as soon as we did the number 3, it eliminated all the numbers between 20 and 30. So our field of options kept narrowing, and we have covered them all. So when I got down here to 6 and 10, I knew that the only other numbers left were 7, 8, and 9 to consider because every set has to come from between the set before it. And when I tested those in the calculator or in my head, they don't work. All right, so we listed the factors of the number we got in step 2. We listed the factors. Now what we know now, since this answer that we started with, this product, is the answer to FOIL. Okay, where the O and the I have been combined, and we're trying to find out if FOIL, the O and the I, if they were, let's say, a 100x and a negative 81x, or were they 12 and 7, or 1 and 18, or, I mean, there's a lot of options here. There's actually an infinite number of options, and if we try and figure it out in our head, it's going to give us a headache. It's just not cool, because it would be so hard, especially with the numbers that we have involved here. So the process we're using is going to take us directly to the answer. We don't have to hurt our brains that way. So what we did is went from an infinite number of options that make 19 to just this many. We have this list, okay? And it's pretty easy to see it in this list, but I will caution you, okay, because sometimes there's two different sets that will work depending on what the signs are. So please don't get in a hurry and choose the set right off the bat. Make sure you put your signs on correctly, and that's what the next two steps are about, 4 and 5, is to make sure you get the signs right. Most people, when they get these wrong, it's because their signs are wrong. So there's a way to fix that for you. There's a way to know exactly what the signs are. So let's look at number 4. It says, look at the sign of the middle term and put that sign on the largest factor in each set. So we put these in a certain order so that all the small numbers are on this row or column, and then all the largest ones are on the right column. So that when we do step 4, when we put our signs on our numbers, it's going to be super easy. So we're going to look at the sign of the middle term, and that's this sign right here. Okay, that whatever's sitting there, if that had said minus, that's fine, or if it said plus, whatever that is, we put that on the largest number in each set of factors in our list. So this is always my large column. So now I know all of these are positive for sure. See, there's two ways to get a positive 60. We could have had both numbers being negative multiplying to make positive 60, or both numbers have to be positive. Now the middle term only tells us what the large one is every time. Then we have to decide with what we know about multiplying numbers. We have to decide, that's step 5, decide what the small sign is. Well, if we know the large ones have to be positive, and these have to multiply each time to make a positive 60, that tells me that my small ones are positive in this case. So that's how we do steps 4 and 5 to get the signs correct. Then step 6 says, now add up each set and find the one that matches the middle. The middle is a positive 19x. So we're looking at our list here, and we want to find positive 19 when we add them together. And right here is the one that equals positive 19. What we have just discovered is the original O and I. It was originally a 4x and a 15x. So now this says once you find that middle term, rewrite the problem as the 4 terms, as the F, O, I, and L separate from one another. So I'm going to replace this 19x with a positive 4x and a positive 15x separately. And it does not ever matter which order. You can put the 15 first and then the 4, or you can put the 4 first and then 15. Never matters, okay? You get to decide. So we have 6x squared. I'm going to put the 4x, and then the 15x, and then we have our 10. Okay, so I just replaced the 19x with the 2 terms, and now we have F, O, I, and L. All right, so now we're ready to do factor by grouping. We can cut the problem in half, and I know the video uses parentheses. I don't like it. I like to do this. I just cut the problem in half so I can see the 2 different sides of the problem. And you ask on the left side, what do these have in common? Just like we did up in step 1, where we looked at the whole problem and said, hey, is there anything in common here? You know, but, you know, 6 and 4, the biggest number they have in common is 2. And then they had x squared here and x, so they also had an x in common. And whenever we find something in common, then we write what's left over in parentheses next to it. So if I pull the 2x out of here, basically I'm saying, hey, I know 2x was in common. If I multiply 2x times whatever's here, I should land up here. So what times 2x gives me 3x or 6x squared? So it's going to be a 3x. Because 2 times 3 is 6, and x times x is x squared. And then do it again. What times 2x gives me 4x? Well, 2 times 2, and we don't need any more x's. Now we can use the same process over here. I will tell you that whatever sign is here has to come down here, okay? But we could just write in this set because it always matches this one every single time. So this set has to say 3x plus 2. And again, we can use that same idea. Whatever was out here has to multiply with whatever's in here in both and take you up to the top. So my question then is, what times 3x will give me 15x? Well, 5 times 3 gives me 15. And then double check it. 5 times 2 does give me 10. Yep, okay. So now, so that was what we did here is we did the left side, and that's where we got this. Then we did the right side. That's where we got this. So now we look at the whole thing, this whole thing that we have written here. And we find the two sets that were originally the multiplication problem. Well, what they have in common is right here. They both have the set of 3x plus 2. And if you got rid of that part out of there, just like when we got rid of the 2x out of these, you write what was left over. We have a 2x on the left side, and we have a plus 5 on the right side. Now, this is the correct answer. You could write them the other way around. You could take what was on the outside of the parentheses first, and then what was on the inside, write it second. And the reason this works is because they're being multiplied. And we know that when you take like 2 times 7, you get 14. But if you do 7 times 2, you also get 14. Switching the order for multiplication is not a problem, because it's called that commutative property of multiplication, where when things are getting bigger, addition or multiplication, you can switch the order of the numbers, and we still get the same answer. It's not a big deal. Okay, getting smaller is a big deal. If you're dividing or subtracting, that's a whole nother story. But in this case, when we're doing this process, we're good. Either way is right.